Hey everyone, this is my first video of the quantum physics series, and we're going to talk about photons in general. This is going to be a very short introduction video. And throughout history, scientists have been arguing, is light a wave or a particle? Newton initially stated that light is a particle. Think of light as a stream of balls. That's how he imagined light. And then after the double slit experiment, we managed to prove that light was in fact a wave. This is because when you got the double slit experiment, you can see the fringes of darkened light, and these fringes are only possible by the laws of superposition. When waves combine together and the net displacement becomes the sum of the displacement of the two respective waves. And this is a phenomenon that only occurs if light is a wave. And now in modern physics, due to many experiments that will be mentioned in later videos, it has been proved that light has both particle and wave-like qualities. But in this unit and in this video series, I'll be focusing on treating light as a stream of particles, just like how Newton talked about. Because, we discussed light being waves a lot in significant detail in the previous units, for example, in the light phenomenon. And quantum physics, we basically focus on how light is a particle. When I mean particle, I mean, for example, imagine balls, imagine discrete objects. That's how we want to imagine light. And we call each discrete packet of light as a photon. And this is the definition of a photon. I don't think you need to memorize it. Elementary particle that is the smallest possible discrete packet of light. But it is very important that you think of it as discrete packets of light. Matter of fact, the quanta in quantum means discrete packets. And so if you imagine light as a wave, then it's something that's continuous, right? But if you imagine light as a particle, it's composed of photons, these photons with their own momentum, with their own discrete energy. And that's how you want to view light that's one of the ways you want to view light in quantum mechanics. And also, this guy called Planck found out that the energy of each photon can be calculated by this formula, where this is Planck's constant. It's in your formula booklet. And F, frequency. So he found out that each photon carries a discrete packet of energy that is worth this much.